In this video, we will explain how to inspect PAC's i3D CT scan from VATEC. Okay, so the first thing that we have to do is to create patient chart. Okay, so that we can just record all our tests um, in that chart. Okay, I'm creating one right now. I'm calling it daily tests. All right, and just make sure that when you create a patient chart, um, just make it an adult, okay, so that the capture software can take those values and adjust the exposure levels accordingly. All right, now once the capture software is open, just make sure to select these settings in here. Use high quality and standard voxel size, and no metal artifact reduction. For the position, just stick to occlusal, okay, for vertical position, and horizontal for a center position. After you select those settings, you can save them if you prefer. Just go to the engineering tab up there, type the password, which is VATEC in lower caps, okay, lower cases, go to Phantom Align, and then just enter in those fields the exposure levels that you see on the lower left corner of the screen. Save your settings, okay, close the window, and then the next time that you are going to perform your inspection, just select this button here that looks like a phantom, okay, like an inspection phantom, and then all your settings that were previously saved will be applied like that. Okay, so just click on the confirm button. This will make the machine start to move, get ready for the next step of our inspection. Once you see that the ready button starts to blink, then you will know that that is when you have to position the phantom kit on top of the chin rest. I will now explain you how to place those phantoms on top of the chin rest so that you can perform your inspections for both CT number and uniformity tests. Let's start with CT number. So this is what you will see. Okay, first you will have to place this piece here, which is called a jig. Okay, this will serve as the base for all the other pieces on the inspection kit. Okay, just insert it on the into the chin block. Okay, and you will see that it has a couple of plastic screws on top. All right, that will allow you to slide that surface, okay, so that you can align the laser more easily. Once you determine the position of the laser, just make sure that you align the phantom, okay, with the laser. The center group of the phantom needs to be aligned with that laser beam, okay, like this. Okay, once you hit the sweet spot, just adjust or tighten up those plastic screws so that you hold the whole surface in place. Next, you have to place the second phantom on top of the jig. This second phantom is the level phantom. and is identified with the number 1, as you can see right here. The jig was identified with number 0, okay, and the level is identified with number 1. Okay, you can see that the level has this level tool, okay, it's a bubble, alright, and the whole purpose of this piece is just to make sure that your kit is properly leveled on top of the chin rail. Okay, so during this first part, what we will do is just to position the jig, which is this platform here, on the chin rest. Okay, this will hold the rest of our kit. Okay, all the phantoms, all the discs that we will use for inspection. Okay, will be placed on top of this jig. Okay, and very important, we need to make sure that the laser beam, okay, um, is positioned right on the middle groove of that platform. Okay, if you use a card like this, okay, you might see it more easily. Okay, you can see the laser beam now. Okay, just make sure that that laser beam is right, as I said, right on the middle groove of that, like that. Okay, you can slide the jig as I just did. Okay, and then once you find the sweet spot, once you find that the laser beam aligned, you can just tighten up those plastic screws, okay, so that you can hold the jig in place. All right. Okay, so after you check that, okay, we can just continue with the next step. All right. Let me show you. Okay, so after you tighten those screws up, as I mentioned before, okay, what we will need to do is to place the next piece on top of the jig. Okay, in this case, it's a level um, phantom. Okay, it looks like this. Okay, you will see the level right there. Okay, it's a bubble. All right, and just make sure that you identify the number of the jig, okay, because those numbers need to be positioned the same way. Okay, so the first one is 0, the jig is 0, this level is number 1. Okay, and all those numbers on the phantoms need to be aligned with each other. Okay, and you will see the uh, level right there, and that bubble, if centered properly, means that your whole assembly for the kit is properly leveled. Okay, if not, you can just use these plastic screws at the bottom of the jig to level your
The
kit
system is moving into
correctly.
capturing
Okay,
position. Please wait.
so at this moment I am about to
The
shoot
system
some
is ready
radiation.
to capture an image. Please
um,
close your
I'm
eyes
stepping out
until
of
image
the
capturing is
path
complete.
of the radiation, and I'm going to press and hold the exposure switch now.
Right this way. And you can look up. All right. Thank you. Thank you. I'm good.
Image capturing is complete. Please open your eyes and follow the operator's instructions.
Okay, my screen is flickering a bit, but that's because of the software I'm using to record this session. So just disregard that flickering. Okay. So after you take the X-ray, um, just open the image that you took. Okay. Um, it will be open in the i3D Plus program. Okay, as you know already, and we will evaluate that image using this software. Okay. Once the image is open, what we will use is the tool called as ROI, or region of interest. Okay, we will focus on this pane here. Okay, the lower left pane, the axial view. Okay, and we will need to read. I'm maximizing the image right now. We will need to read the city number on these materials here. Um, water in here, Teflon in here, this one here we don't use, which is acrylic, and air on the opposite corner of the Teflon. Okay, and this is a tool, region of interest. Just create an area of about 20 millimeters square on each of those regions. So this is for Teflon first. Okay, as you create those regions, you will see in the label what values they have. Okay, all right. So those three regions are air, Teflon, and water. Okay. Now, the nominal values for those materials are 1000 Hounsfield units for Teflon, um, 0 Hounsfield units for water, and minus 1000 Hounsfield units for air. The tolerance ranges that we are working with are 200 plus and minus those nominal values. So let's say if for Teflon you have something between 800 and 1200 Hounsfield units, then we are fine. Okay, so after you just uh, evaluated your region of interest, just take a screenshot as I just did, just to save it into your imaging software. Okay, and then we are ready to take another x-ray, in this case to evaluate uniformity. Okay, so the machine is moving right now into the capture position again, and once we have the confirm button blinking, we will proceed uh, to show you on the machine exactly how to do the next step. So right here, okay, remember that in our last test we had the
The system is
city
initialized.
number
Please wait.
phantom on top. Okay, so as we initialize the machine for the next CT scan, the machine will move. Once the machine stops, we will remove that top city number phantom, and we will place a uniformity test phantom instead. Okay, right there. So when you see the ready button blinking on the screen, as you know already, it's when you position a patient. Usually, in this case, we are going to position the phantom correctly. So as I just said, let's remove the top phantom. Okay, which is the city number phantom. And this is the city number phantom, and let's place instead the uniformity phantom, which looks like this. It's a solid disk and is marked with number 4. Okay, you can see it like that. All right, so we'll place that number 4 phantom, okay, on top. If you have some hard time putting the phantom in place and maintaining the level of the whole kit, just remove the the level phantom like that, and just try to put those two together like that, flashed. Mhm. And then just put those two on top. Okay, let's make it easier that way. Okay, just evaluate the level again and the alignment of the laser. Okay, for this test we need to check those two laser beams again. Okay, the one on top that needs to be right on top of the center groove of the top phantom, and the horizontal laser beam that needs to cross the midsection of the top phantom as well. So let's use the card again. Look at that, the laser beam is right on top of the center groove of the phantom. So this is aligned, that's correct. And if we see the phantom from this other angle again, we can just determine if the height of the chin rest is correct. And those are the controls that you know that will allow you to adjust that height. Okay, so let's place the card, and that's too low, so I need to raise the chin rest a bit so I can see the laser crossing the midsection of the top phantom, about there. You can see the laser there. Okay, so depending on the light conditions of the room where you take the x-rays, you might not need a card. In this case I do. Okay, alright, so once you have
The
your
system
whole
is moving into
assembly
capturing
in
position.
place,
Please wait.
you go back to the computer and just confirm on the screen by clicking on the ready button, which should be blinking.
The
At this
system
point,
is ready to
the
capture an
X-ray unit
image.
is
Please
ready
close
to
your
take
eyes
a new
until
CT
image
scan.
capturing is complete.
So here we go. We are about to press the exposure switch now. And let's shoot like that. After we finish with our X-ray, the machine will be back to the 0 position. And as the image is reconstructed in our program, we will be able to evaluate this new CT scan using our i3D Plus CT scan viewer.
Image capturing is complete. Please open your eyes and follow the operator's instructions.
So here I'm showing you the reconstruction process. You might feel that the reconstruction process takes a little bit longer than usual, but that has an explanation. Remember, I told you to take X-rays using the biggest field of view available in your machine, and that is precisely what we are doing. Okay, so after the image is reconstructed, just save it for your records. Once you open the CT scan that you just took, let's work again on the axial view. Okay, let's maximize it. Alright, and what we will do now is to create regions of interest again, but in this case 25 millimeters away from the center of the phantom. So let's try to measure 25 millimeters away from the center first using this measurement tool, like that. I will create four distances, okay, um, in those four directions. Okay, let's call them north, south, west, and east. You don't have to be perfect with the distances, just make sure that they are all about 25 millimeters. So this is our third distance here, 25 millimeters as well. And finally, let's create one more, about 25 millimeters away from the center. Okay, so using those four distances as a reference, let's create now our regions of interest, which will be positioned at the end, okay, of these distances. Just try to place them in a nice spot, okay, so that you can see the labels and you know what label belongs to what region of interest. Okay, um, try to draw those regions of interest so that they are about 25 millimeters square each. That is the area recommended by the manufacturer. Okay, so we've got now four regions of interest. We need to draw one more right at the center of the phantom, where those two arrows uh, are joined, right there. Okay, so now we have five regions of interest. So the purpose of this test is to um, find what region of interest has the highest average value and which of them has the lowest average value. The average values can be read on those labels. So just find which one has the highest average value and which one has the lowest average value. If the difference between the highest average value and the lowest average value is less than 400 Hounsfield units, then that means that the CT scan machine passed uniformity test.